going to be a long one here. This again to show you, thanks, what our fuel results are and how they really break down. So again, we're at an 8% natural gas, which is something that's wonderful. Our process needs about 3% natural gas to actually run. We have a surplus of natural gas. We are creating gasoline. Originally, we were tuning the machine all over the place. So originally, we were at almost all gasoline and natural gas. We also went down at the other end. I was talking to some MIT professors, and they suggested we make white oil out of aliphatics instead of aromatics. I'll get into that in a minute and what that all means. But essentially, they were saying, let's make some oil for Goodyear and tires that they're required to use now, which don't contain the carcinogens in them that aromatics have. So we were moving the scale all over the place, and finally, in the end, with the help of ILChem, they definitely agreed that making diesel was the best product in the world to make out of our machine. So this, again, is what a gas chromatogram actually looks like. And this is generally what you're getting out of a crude. This would be out of out of an old stripper well. So you have your light ends, then you have your gasoline here, then you have your diesel in here, and this stuff here is the waxy tar, asphalt, all the stuff you don't want. It comes up from the ground, they have to deal with it, and it's a problem. Our process right now, because of ILChem in the end and the kind of tuning they've been able to do to take the variables out of our process, we consistently make this, and it's gorgeous. Look at the peaks, they're incredible. We've got natural gas, we have some gasoline, we have a heck of a lot of diesel, and right down there, around 20, we have no heavy ends at all, no wax product. It flows beautifully, it looks great, it's an amber fuel. We've had it tested by Intertech and Petrolabs, and the reports are incredible. The only thing that ILChem doesn't like is we have a bit too much gasoline or light ends in it, which they're helping us with to remove through what generally refineries would do is put a second condenser in to basically tap off the lighter product so that our diesel can go directly into the engine. Our diesel is better than most other diesel products. Our sulfur content is trace or no trace at all. We have no water and we have no sediment. So it's a dream for refineries. They love this. Their whole job in the end is to try and get the light ends off, and we produce them all day long. So from this is what ILChem did to our blessed. So and they are an incredibly talented group. They're very passionate about what they do. They were Occidental Chemicals R&D lab privatized as ILChem. And these guys love working on molecular organic chemistry. And so when I first went to see them with Alan and we took our stuff, they looked at me like we were crazy. They did. They were skeptical. They thought, there's no way this is going to work. You can't possibly get any kind of energy conversion. Everyone that's trying it, microwave, infrared, all those, it costs so much energy to break down the plastic, the end fuel product isn't worth, you can't recover your money even. So they said, I said, well, our energy conversion is about 2,000 to 3,000 BTUs for 44,000. They looked at us like this and went, no. So we engaged them on December 9th, and they built this. At the same time, we also built a 1-ton processor, so they were able to test. Basically, their job at this time was to say, okay, you guys built it this way. We wouldn't do this in our lab because there's just far too many variables, and we're going to eliminate them. So they built this incredible architecture around it to capture the off gases, to capture the residues, to analyze everything they can. What you don't see in this picture is all these tubes are going off to various machines to analyze the fuels and off gases and residues. So here's our 1-ton unit. So with the small unit, we wanted to make sure it's scaled, and really, so did ILChem. So we went off and built, after we bought a Chinese machine, a 1-ton processor like this. We built it fairly quickly. Up top, I'll show you, the red bar is actually a feeder into the system. This is a continuous machine, unlike the blessed unit, so you don't shut it off. It runs 24/7. You feed plastic into it. The very top chamber up top simulates the unit that we purchased, our large 20-ton processor. It has a rotary reactor in it. The fuel comes out into a condenser, into various stages below, through a water seal, and we get our fuel off. So what was really nice about this 1-ton is anything that ILChem had figured out what we should be doing in the lab, we were able to test and make sure that it did scale properly, which it did. And they really helped us, and they helped us through this whole process of designing and building this unit. This column here on the right-hand side up with the blue handle on it was actually a manual catalyst feeder in case we had to feed anything else into it to try and make this thing go. In the end, it did run fairly well and fairly quickly, but then we moved on to a much larger machine, which I'll get to in a minute. Again, we have our catalyst column here. We had a screw feed system into the main reactor, and we had it monitored with our controls came off into our own systems. Finally, our 20-ton processor arrived after sitting in customs for a very long time. There's a group of 3 of our staff realizing that we really need to own a building with a crane, and a big one at that. So China Shipping showed up at our door in the fall with our first container, which included the other half of the processor. We opened it. We leased a building here from a shareholder here at Nap Money. The truck came in. We looked, we can't get this stuff out of here. It weighed tons. Like the concrete alone and the part that goes around the rotary reactor was around 15 tons, and we had a 3-ton tow motor. So we had them leave the truck. We had to go out and order cranes and have all the equipment pulled out. And this second container, they were really, really helpful. They thought they were doing us a favor so we wouldn't burn our hands. They shipped us a pair of asbestos gloves, and they put them in the reactor. So as soon as this arrived in BC, we had a wonderful time. Health Canada came in. Everyone came in. This thing was quarantined so fast. And so it took us 2 months to bail it out and get a group to come in, a whole cleanup team. They set up a tent around it, opened up the container, came in there with their spacesuits to remove a set of asbestos gloves. And that was 2 of the longest months of my life, waiting for that piece to come so we could rebuild the big guy. And that reactor there that you're looking at is about 6.5 feet in diameter and 18 feet long. So when you looked at our little 1-ton and our little blessed, that's just the reactor part. It's huge. You can put a lot of plastic in there fairly quickly. So in Q3, we learned a lot. We acquired 3 companies. That was hard. Get all the accounting and financials together. We're scaling up P2O at an enormous rate. We're dealing with the chaotic public markets. Then we're dealing with chaotic data from NASA, because it's the same thing. And really, we had to deal with the delay of our processor. We had to integrate and build a company with management to figure out how to make this plastic to oil go. Because it's great, we have this machine that does cool things, but we have to have a unit behind it, an infrastructure to actually get it out in the market, lock up feedstock, get agreements, build sites, permitting, all these things that go into really launching a really successful product. And so right after that, we also had a real challenge here, and this is where Ron Baldwin came in, and he saved the day. We had to somehow consolidate the financial systems for all these different companies, and Packet came with a really added benefit and bonus. Unlike every other company in the world, they didn't use QuickBooks or Simply Accounting. They rolled their own accounting system back in looked like the 40s, but it was really the 80s. And so Ron had to rebuild their accounting back from basically cash statements back 2 years. And so he kept his head down in their invoices and books and bank statements for several months, building us a set of financial statements that we could depend on for public reporting reasons. So that was a huge challenge in itself. So while we're dealing with, the plastic to oil scale-up, Packet, sales, investors, everything else, then we've got this wonderful accounting thing that's just volleyed into our court. Quarter 4 was a lot more interesting for us. So we got through the chaos in Q3. We got pretty comfortable with our plastic to oil process. We're still running pretty small at that time, but we consolidated all our information from testing. So basically, we documented the heck out of what we were doing and figured out what works, what doesn't, how we were doing it. We still didn't know everything about it because we just didn't have enough equipment to analyze it. We knew what we were approximately getting. We'd send off our tests to Intertek. Intertek would come back and say, yeah, fuel's great. We'd do the ASTM specs, but we still didn't know all of the variables and how to really control